The moon is old. At least it looks old, since its entire surface is strewn with the rubble of broken down rock and pockmarked with scars from ancient asteroid impacts. We know that rocks weather here on Earth too, and that meteorites have made some considerable dents over the years, but today Earth looks reasonably fresh and new without widespread craters. Earth owes its youthful appearance to the fact that its outermost layer is constantly renewing itself, hiding its age. New rock spills onto the planet's surface from the mouths of volcanoes. Magma is released at the seams of ocean floors and cools to become part of those floors. Rocks metamorphose and mountains form when continents collide, and the seafloor is recycled as continents ride over it. The process of remaking rock doesn't just make it look young, it makes it young. At least to us, because our best tool to date rocks is to measure the amount of decay of certain radioactive elements in the rocks. And when rocks melt and reform anew, all evidence of that decay is destroyed. Normally this is great, because it means rocks carry around a record of their age, the time since they formed. For example, we can tell that ocean floors are spreading because their rocks are youngest near mid-ocean ridges and get progressively older as you head towards land, where they're often recycled by sinking under continents. However, because the Earth remakes its rock so much, and because remaking rocks resets their built-in clocks, it's hard to look really far back into our planet's history. Most of the first solid rocks that formed ages ago on Earth's fiery surface have probably long since been remade. And that's where a resilient little mineral called zircon comes in. Zircon is similar to quartz, both in its chemical structure and in its durability. They both stick around a long time after other minerals weather away. But zircon also has two things quartz doesn't: zirconium, which gives it its name, and small traces of radioactive uranium. Uranium atoms are similar enough to zirconium that they can occasionally slip into the mineral's crystal lattice in zirconium's place when the mineral is forming. But unlike zirconium, the unstable uranium atoms eventually radioactively decay into lead atoms. Which is weird because lead isn't similar to zirconium and so would never have ended up in a zircon crystal on its own. So the more lead you find in a zircon crystal, the older you know it is. And one of the oldest terrestrial minerals ever found, quite possibly the oldest piece of the Earth we know of, happens to be a very lead-filled grain of zircon found embedded in sandstone in Western Australia. Somehow, this crystal has managed to escape destruction by erosion and volcanic eruptions and asteroid impacts over the millennia. And while we don't know whether it formed in the very first rock on Earth, if it didn't, then by definition the first rock must be even older. So despite Earth's best efforts to hide its age from us, uranium-lead dating of little bits of zircon tell us our planet formed at least 4.4 billion years ago. There's also other evidence from meteorites that suggests the Earth is even older, but at bare minimum, this zircon lets us say with confidence that the Earth is literally older than dirt. This video is supported in part by our Subbable subscriber iFixit.com, the world's free online repair manual with free step-by-step repair guides to fix all your stuff, from the bicycle you ride to the smartphone in your pocket. Check out iFixit.com/MinuteEarth for repair manuals, parts, and tools so you don't have to throw away what you can fix.